Now, discussing these technologies is important because although they may not be 802.11, they still exist within the wireless spectrum and can interfere with our 802.11 networks. Now, for clarification purposes, a lot of folks will misuse the term noise and interference. Interference comes from 802.11 devices. If I have an access point in one building and another business has a different access point, they're both using 802.11, that would technically be interference. Noise comes from non-802.11 devices. So a lot of folks will say, well, isn't noise a type of interference? Yes, but for the exam, interference comes from other 802.11 devices. Noise comes from non-802.11 devices. I'd just like to clarify that. So technically what we are talking about here is noise, just to clarify. So some of these technologies you're probably familiar with. Others you may not have heard. Others are dead, like WiMax. But Bluetooth is ultimately used to form wireless personal area networks. It's integrated into phones, tablets, laptops, desktops, etc. Extremely low power consumption, which makes it useful for battery-powered devices. Several versions are mentioned in the IEEE 802.15 standard, but that standard is no longer maintained. That's something we mentioned yesterday. Bluetooth development is primarily controlled through standards developed by the Bluetooth Special Interest Group. The latest version, according to the exam, is version 4. Now, the devices themselves are grouped according to their radiated power. Classes 1 and 2 are the most common and have a range of about 35 feet. Now, Bluetooth Low Energy, BLE, was designed with IoT in mind. 20 dBm over much greater distances, right around 100 meters. Now, up to 8 devices can be part of a single personal area network. One of those devices will take the master role. Another term you'll hear for a personal area network is a piconet, but it's usually limited to about 8 devices. Now, how does this factor into 802.11? Bluetooth uses the 2.4 gigahertz band. It uses frequency hopping spread spectrum, and it can interfere with our 802.11 networks using the 2.4 gigahertz band, but only if you have a saturation of Bluetooth devices. Because their power levels are so low, they barely even register as a blip on the radar of our client devices or our access points. Now, in the unlikely scenario of 50 people with 8 Bluetooth devices apiece, all transmitting information at the same time, yeah, you may notice some negative impact on your network, but those situations are few and far between. The impact is felt more on the devices, the client devices, as opposed to the access point, just because the coverage area is relatively small. And the other thing to factor in with Bluetooth is unless you're streaming music, to a headset, they're not always transmitting information. It's kind of like turning a light switch on or a light switch off. If I'm sending something to a Bluetooth device, that transmission goes out, and those devices, they're not actively transmitting information. So you barely even notice them, once again, unless there's a ton of them all within range of a single access point. You may notice some negative impact. Another technology that the exam mentions is going to be ZigBee technology. It is primarily used with certain devices as part of the whole smart home movement, wireless controlled outlets, wireless controlled light bulbs. What are some other things that are out there? Blinds that open and close, you can control them from an app. Once again, they do utilize the 2.4 gigahertz band. They do utilize very low power consumption, and even more so than Bluetooth, just think about how the functionality works with ZigBee. If I want to turn my lights on, I generate a signal to turn those lights on, they're on, and that's it. When I want to turn them off, I generate a signal to turn the lights off, and they're off, and there's no transmissions from there. So kind of in that same boat, if everybody at the exact same point in time within a single wireless cell generates a signal, you might notice some interference, but those situations are few and far between. Nevertheless, the exam mentions ZigBee by name. Now, something that, man, it's been a long time since I've seen cordless phones in a business environment, but they are still out there to a certain extent. Most of us use our smartphones now anyways, but the key thing to remember with cordless phones is that they operate in a 2.4 gigahertz band, and they do cause a significant amount of negative impact, if you will, on your wireless network. That's because cordless phones are using a constant communication. When you're talking to somebody, that connection between the base device and the phone is actively going, so they are actively transmitting information. But probably more so than anything else, the power level rises all the way up to 250 milliwatts. We just got done discussing the other day that most of our devices, 100 milliwatts, where if you translate that into watts is, 0.001 watts. 250 milliwatts completely overwhelms our access points and our client devices. So if somebody's talking on a cordless phone, or 10 people are talking on a cordless phone, you're definitely going to notice more than likely no connectivity whatsoever, because they will completely overwhelm your wireless adapters. Now, the other thing to factor in is microwave ovens. Goes into your site survey process. You'll probably notice that every day around lunchtime, your wireless network kind of slows down altogether. That's because the inside of a microwave oven can generate upwards of 700 watts, not milliwatts, watts. And the leaked energy, it does actually escape out of the box, can interfere with the access point and any other sort of 802.11 devices. So the most important mitigation techniques we have at our disposal, most cordless phones will have a little switch where you can change it from 2.4 to 5.8. Remember that in the 5 gigahertz band, most of our frequencies go from 5.0 to 5.7. So 5.8 is a different band. That'll basically mitigate the entire impact you would feel there. As far as microwaves are concerned, commercial grade microwaves, those that they make for restaurants, have higher quality RF shielding. They'll actually heat up your food better, but from a wireless perspective, they'll keep much more of that leakage inside the box. So those are the only two mitigation techniques that we have. Yes, WiMax is dead. Yes, I know that it's not actively being developed, but it is still mentioned in the exam objectives. WiMax was primarily used to provide that last mile coverage. It does use some of the frequencies that we find with 802.11, but it slightly changes the signal. And really, if we do have a ton of them within range of our wireless network, we may notice an impact on performance. Despite the fact that they use the same frequencies, the likelihood of them being a source of noise for 802.11 networks is slim to none, especially when you factor in that they're dead to a certain extent. But you may get a question or two talking about the worldwide interoperability for microwave access, otherwise known as WiMax. It does officially provide the last mile broadband to consumers in a particular area. It was published under the IEEE 802.16 standards, and it operates between the 2 and 11 gigahertz band, as well as the 10 to 66 gigahertz band. More often than not, WiMax operates in bands higher than our wireless network. Very rarely, if ever, did you see them operating in the 2.4 or the 5 gigahertz band, because they are providing that last mile coverage. They're going to use much higher frequencies to generate signals much farther. It could technically interfere with 802.11, but those situations are highly unlikely, once again factoring in that WiMax is no longer being actively developed. Just to kind of round out some non-802.11 interferers that we didn't previously mention, video game controllers. I know some businesses are all about work-life balance and kind of having a unique environment. So you might have an Xbox, you might have a PlayStation on premise. Those controllers use the 2.4 gigahertz band. They can interfere with our devices because there's an active connection, because you want to make sure that the buttons work when you press them. Some other things that we didn't necessarily mention that the exam mentions by name Canopy. Canopy was Motorola's fixed wireless broadband technology. It uses, amongst other bands, the 2.4 and the 5 gigahertz band. Some other devices that may be used as part of intentional interference, for lack of a better term. Continuous transmitters generate waveforms that can negatively impact our wireless networks. Jammers are specifically designed to disrupt radio signals. Inverted Wi-Fi is where the RF signal components are just a tick off of what they are normally to be expected. Similar to a jammer, but the idea behind Wi-Fi inverted is that you have one device that's inverted communicating with another inverted device. They appear as noise to our 802.11 devices. Wi-Fi invalid channel. Let's say that you're using a non-standard channel. So we saw like 2.417, 2.422. What if you're using 2.418? That's considered to be a Wi-Fi invalid channel. That of course can cause overlap with our 802.11 channels and therefore have a negative impact on performance. Video cameras transmit in the 2.4 gigahertz band as well as the 5.8 gigahertz band. They can obviously serve as sources of interference. What are some other things that are out there? Wi-Fi inverted, we talked about that. Wi-Fi invalid channel, video game controllers, jammers, continuous transmitters, and canopy. That just kind of rounds out those. They don't fit into any one particular area. They don't fit under any one particular IEEE technology. They just so happen to use the same frequency bands that we find on our wireless networks.